Thank you so much for coming, and especially during lunchtime. And it's my privilege to introduce this amazing set of panel speakers to talk about the AI ecosystems. So let them introduce themselves.
Hello, I'm John Belazier, CEO of Soluna Holdings. We build green data centers for AI to support large language model training and tuning and inferencing powered by renewable energy.
Hi, I'm Peter Wang. I'm the co-founder and the chief AI officer at Anaconda. And we provide open source and enterprise solutions around Python, data science, and accelerated Python for machine learning, data science, AI, all that.
Hi, my name is Arpit. I'm a partner at Threshold Ventures. We are an early stage investors, typically investing at Series A, Series B stage companies across the enterprise AI stack.
I'm Paul Farnsworth. I'm a career technologist and been an IT leader for almost 30 years. So implemented technology in large and small companies. I'm currently the CTO for DHI, and we operate dice.com and clearancejobs.com.
Fantastic. You know, I forgot to introduce myself. I am Lin Wu. I'm a professor in a Wharton School. So let me start off with a question. So since we're talking about the AI ecosystem, hardware, cloud, enterprise integrations. So when I think about this ecosystem, I think of the chip at the bottoms, the GPUs. And then we see the cloud providers sit on top, provide all the compute resources. And then we have the foundation models, the OpenAI, the Llamas models on top, sit on top of cloud to get trained, get inference there. And then you do customized applications. Okay, so when I think of this ecosystem, and as a company who is not necessarily digital native, but trying to get into the generative AI space, what do you think is most constraining factors for them to enter this ecosystem?
So I start. I've changed my answer. We chatted about this earlier, and I said chips, but I've changed my mind on chips. So I'm moving on from chips. I actually think it's talent at the moment. I think there's a little bit of hype around what the technology will do. There's a lot of press with big tech consuming huge quantities of chips and all the hardware that's required. And I suspect what probably some of the decisions that enterprises are making are twofold. Leveraging this kind of technology internally for their own use and then building their own products using this kind of technology. I think it's probably going to be a bit of an issue with finding the right people to help, particularly if you want to build your own product and not just leverage what's in the ecosystem. So I changed my answer.
Great. So building your own product, using leveraging own data. Okay, great.
I think for me, especially at the intersection where I look at for net new companies and looking to invest in those businesses, I feel a lot of enterprises are still at the very early stages of moving products from prototyping, staging to deployment and production. So I think that crossing the chasm still has to happen. And I think part of the reason is there is a very high level of security requirements that the model should not be hallucinating, and just the general health of like what's the expected output, especially in an enterprise setting, that I think companies are looking for, which hopefully as you kind of get better with models, etc., will get solved. But I think that's probably one of the constraining factors that we see all the time.
So there's many constraints, but I think probably the one that's the hardest for businesses of the type you're describing to get over is actually making the organizational commitment. I think a little bit of the synthesis of both what you guys said, really having that organizational commitment, not to just do some POCs or create a center of excellence and, make the board happy to show we're doing some AI stuff, make the investors happy talking about some AI stuff, but actually realizing and sort of facing the idea that there is an existential transitioning that's happening. It's not, it's fits and starts, but we're definitely going to be crossing this huge AI sort of portal. And for businesses to be ready to do that, they cannot adopt the same posture towards talent, towards IT architecture, towards governance and compliance, towards these kinds of things. So the biggest hurdle for them is really, from a business strategy perspective, is that organizational commitment that this is an existential jump we have to make. And we can't do it sort of the way we did big data and data science and where at the end of the day, you still go and buy a pile of expensive vendor stuff from a pile of the same vendors and you call it done. That's not going to happen with this. You really have to revisit your data silos. You have to revisit what is your purchasing strategy at the hardware level. You have to revisit how do you empower lines of business to actually be self-actualized, to adopt technology. All these kinds of things are organizational transformations that businesses have to deal with.
Yeah, I'd like to plus one that prior to becoming CEO of Soluna, I spent 25 years selling lots of stuff to enterprises that could transform them. And for the most part, what they've been looking to do all that time has been to leverage their data to give them insights to make better decisions. And this is the first time where we are seeing technology that has the real potential to do that. Give them the ability to sit down at, the CEO to sit down at his or her desk and say, what should we be focused on today? And to go from that to actualizing that vision, enterprises now need to build their own set of specialized infrastructure, resources, expertise, a whole set of things they've never done before. And they have no idea how to start doing that. They don't understand. They have a concern about the fact that, they're going to be using their crown jewels to leverage this technology. And where should they put that? Do they have to go back to building their own IT environments? What tools are they going to need? What talent? There's so much to talk about in this bouillabaisse of sort of, decisions to make. So there are a lot of challenges ahead for the enterprise.
Okay, well, going back to the tool, so organizational challenges are very, very real, very, very important. But I'm curious about technology challenges. Some of you alluded to. What kind of advice would you give them to, what are some really important challenges, and how would you, overcome some of the challenges if possible?
Well, we see a lot of enterprises trying to put this new AI-focused equipment in their traditional data centers, and they're running into massive amounts of power and design challenges and cooling challenges. This isn't your sort of run-of-the-mill, servers that you're going to drop into these buildings. You have to rethink the whole environment. And so enterprises are going to need partners that can develop specialized data centers to support their IT environment. And guess what? The power consumption of this equipment, at least today, is 10 times what it was for all the other equipment that they own and will own. And so these facilities really need to start thinking about where they're going to source their power from. And we have to think very laterally about, as a whole industry on a global basis, where that power is going to come from. There's discussions of, 20 gigawatt plus just in the next 24 months of demand for this stuff. There's nowhere that power is being made. And so you have to think differently. In our case, we look at wasted energy that already occurs in the renewable energy space, so you can build data centers around it. But the point is that just saying, hey, I'm just going to put this in the cloud, or I'm going to just put this in my own data center, is not there's no simple answer to that. It's a much bigger challenge.
Yeah, I'll go one level up the stack further. So power in order to facilitate and enable, to empower those chips, right? So then my next level up is once those chips are powered on and they have pipe and they have ping and they have cooling, then the software you run on them for these AI applications has a very different kind of characteristic than the kinds of software that people have been deploying. If you're a .NET shop or you're a Java shop or you're this kind of thing and that kind of thing, a lot of the enterprise business applications that people develop in-house, not the SaaS stuff they kind of use a SaaS provider for, but really the in-house kind of applications that are rife in every business, those tend to be developed really in, I would say, still a 2000s era approach towards software develop, the SDLC, software development lifecycle, right? And ALM, application lifecycle management. It's still very much this perspective of we're writing things that go and pull from this database, present a UI, do some things, and then push another database. And all of these AI applications, and I see this as an extension of the challenges that people had enabling data scientists, because data science and machine learning had a lot of similar characteristics to AI, which is that people need to do lots of math, and a lot of math, and it's bursty, and it's not predictable, and it varies depending on what they find in the data. So that's really unlike when you're trying to build a traditional application. When you say, well, okay, what is the schema of the data coming in? What is the correctness? What are some system tests? And then you deploy it and you kind of know what it's going to look like. For data scientists, for AI kinds of applications, depending on the data, depending on the day of the week, depending on what you discover in your data exploration, you may suddenly need to use a completely different algorithm. You may need to use a 10x, 100x different kind of infrastructure. So this idea that the hardware and the network and the power even are variable dependent on the values of the data is something most IT places just have never really thought about. And so that's a technology challenge, again, tying to an organizational challenge and a mindset challenge.
Yeah, I'll maybe push that thought a little bit further and specifically talk about data. I think there is a general consensus that we're running out of publicly available data to kind of train large models, small models, and whatnot. And there is a fine balance that I think will happen between publicly available data and synthetic data. I think there are specific use cases where synthetic data, specifically in the privacy preserving cases, like for example, if you're creating a model to kind of replicate your user behavior for loan applications where you don't want to reveal your user's profile, but you can create a synthetic profile. So I think there is a definite use case where as more and models come into the forefront, we'll have a balance between what is publicly available, the various data partnerships that we are constantly seeing happen with large tech organizations and actual data owners, and then on the other side, synthetic data providers.
I have a desktop computer under my desk at home. Recently started playing Satisfactory, which is excellent. If anyone hasn't played that, download it. It's brilliant. But that thing makes my NVIDIA graphics card go crazy. And the amount of heat that comes off that one machine, I have a lot of sympathy for the issues with energy that's in there. But I think one of the really interesting things about this is we have to monitor as an industry how much waste we generate. And I think about Douglas Adams and his Marvin, the paranoid android, who said, my brain's the size of a planet, and all you're asking me to do is pick a piece of paper up. We risk having enormous capacity in the cloud and asking these models to generate limericks, which is a terrible, terrible waste. So I think there's going to be some evolution here around sizing. It's unique because in my experience, IT departments and engineering departments have tended to start with smaller resource than they really need and grow. We seem to be coming backwards here on this one, which is kind of interesting.
If I could just add one more thing to that, it's good to bring it up. A fun sort of little piece of information to have in your back pocket. I think someone did the calculation, and each image generated I think by like OpenAI and ChatGPT, each image generated takes the equivalent of a single cell phone's full charge. So just from a power perspective, thinking about what happens when you're doing millions of these things just for the lulz, okay, that's fine. But integrated across a massive user base, it's a lot of power.
Totally worth it.
And don't forget about the water consumption because of current data center designs. You're talking about millions of gallons of water every time we're going through one cycle of training of these large language models.
Okay, that's awesome. So let me get back to the data and also the models and energy consumption. I heard something about synthetic data as being useful. That might be helpful for the cases that we may run out of real human data. And we'll talk about that large models are growing bigger and bigger, and that might require exponentially greater compute resources and energy. And what is your thoughts on the trend, how it's going, and ways that we can potentially alleviate these problems?
Yeah, I think, again, if history is a kind of you can use that as a model. We've predicted the limit of compute power. We've predicted the limit of memory usage. We've predicted all sorts of things. And the wonderful thing is that humans find a way to innovate around all this stuff. So I think there's going to be a continual curve there. I do think, however, data in specific areas, and I know I'm also on the board of an AI startup that's looking specifically at ultrasound data. And the ability to get quality data to train the models on is actually the biggest constraint in that startup. It's not access to infrastructure. It isn't talent. It's actually getting quality data. And then it's also providing the right level of trust within the organization for businesses to allow us to use that data becomes quite difficult. So there's a lot of potential here. I heard in the keynote yesterday, what's the future of this? And it's going to be looking forward to advances in medicine. Some of this is going to have to come down to trust and data. It's its access.
I think you talked about like large models versus small models. I think the way we think about it, at least from the investor lens, is there will be a world where both the large language models and maybe huge language models will exist, and also small language models will exist. I think large language models are particularly good at context understanding and text generation, whereas small models are very good for like real-time processing and specifically on edge devices, if you will. So I think from our I think vantage point, we see that like organizations across the stack who are building large models and small models kind of coexisting and kind of doing what they're doing really good.
Yeah, I agree with that. I think right now, a lot of the discussion of certainly the chart topping sort of their headlining sort of use cases are these general purpose, state of the art, massive LLMs trained on just a ginormous amount of data. And they can, write Shakespeare or Eminem lyrics. They can they can talk about cars and history and the history of the Roman Empire, all these things. But there's very few applications in which you need Eminem to explain to you the history of the Roman Empire and also certain aspects of bioinformatics, right? That's just almost too much to put into one thing. And if you sort of look to the side of that and say, well, if we didn't need all of those things, that's very interesting for a chatbot or for some image generation. But if we actually need to go and talk about the business use cases, which most of the times is diagnosis, prediction, right? Looking for fault detection and characterization, those kinds of things that are all tied to sort of the origins of computing in the first place, which is prediction, anomaly detection, things like that. And those kinds of predictive models are very narrow. They're very domain specific. You can use LLM sort of techniques to apply to those domains and end up with very targeted, smaller quantities of data that can generate very, very interesting kinds of results without hitting this like, oh my God, we're out of random Reddit comments. What will we do? Well, you don't need random Reddit comments to diagnose like ultrasound or to characterize ultrasound images. So I think we will see an absolute, those are use cases. There will be use cases for those large language models, general purpose things, but there's a ton of use cases. I think most of the real world ones that hit enterprises, and that will be the first to really enter into regulated engineered systems. Those almost certainly be much more domain specific, have much more characterization around the kinds of data, and it will be much less black box. And we're right on the cusp, I think, of cracking that nut of interpretability and of really turning this into something we can engineer rather than a black box that we, cast spells on and hope it gives us the right answer.
Yeah, I want to make a couple of comments. I think the first is I have trouble subscribing to the notion that enterprises don't have enough data or the large language models have a data starvation that's coming down the pike. I think that is true because the primary focus of the energy around large language model development and training has been around AGI. They want to make these things incredibly expansive in their application and so forth. And the truth is that there are thousands of businesses out there that have lots of data, most of it unstructured. There have been investments in data maturity and predictive analytics and machine learning activities inside these businesses. And it's actually been hard because you had to kind of structure the information and make it very specific to the prediction that you're trying to do. And that took hundreds of millions of dollars of investment. And mostly you just got some reports that you can run, here and there. But the promise is that you can take these large language models, these NLP focused technology, and point it at your proprietary information and not have to worry about sort of, structuring it in a way that is tuned to that specific application. You can just point the model and the LLM to learn on all of that information. And then ultimately you have your own internal, for lack of a better word, sort of AI agent that can talk to you about what's happening in your business in any different domain. That's a very powerful tool that is, not being talked about. Most of the benefit of this technology will be on the enterprise side. Every business in the world will have the ability to leverage AI to enhance their decisioning, improve their manufacturing, find better pharmaceutical solutions to some of the world's most biggest challenges. I think that there's plenty of data to make that happen if we use the technology the right way. And when we get to that, I want to kind of talk about what I think the enterprise stack looks like for that.
Well, why don't we talk about it now? Let's talk about enterprise stack. Yeah.
Sure. Look, I think that every enterprise is basically going to have their own data science organization. Much like if you look at the large, social media companies, they've been quietly doing this in the background for many years, right? They've been using large quantities of scaled data and information to essentially enhance a business focus on advertising. Well, every business wants to enhance the business that they're in. And so by leveraging the information and data that they have in a very intentional way, they can accomplish that. And I think it's going to play out something like this. Most enterprises will take the either proprietary or the open models out there and bring them in-house into an environment that they control and own, so that they know that there's no data leakage and potential data privacy concerns around their IP. They will put them in a specialized facility specifically tuned for this purpose, and they're going to tune those models for a number of different applications within their environment, and then they will push that out into a host of inference or deployment applications that can be used throughout the enterprise. The most common use cases we've seen right now are chatbots, but I guarantee you they're going to be a lot more than that, way more. We're going to look at agents that help us to rethink how we do business deals. We're going to look at agents that help us to think about how to find new markets for the company, for their products. All of those types of applications will become available. And what's interesting is as you use those applications within the enterprise to leverage this technology, you're going to generate new data from that. Through the experiences of enhancing customer service with your customers, you're going to generate new data, and that's going to then require you to re-push it through the tuning process for the models that you have in your data science environment to enhance the experience going forward. So that loop, if you will, points to me to structured investment in infrastructure that enterprises will own that will become proprietary and core to them. And they will leverage all of the enhancements in LLMs going forward. What say you, my panelists?
It's very depressing. I'll tell you why it's depressing, because I just spent the last 10 years getting rid of all my data center technicians and not worrying about having custom hardware and infrastructure in a data center and moving stuff to the cloud so I don't have to get up and worry about monitoring this stuff and making sure it's running. And I suspect you might be right that there's going to be some shift back to that data center environment that's owned by enterprises. As a CIO as well as the CTO, I don't want that discipline really in my business. I don't want to have to deal with depreciation of capital and large capital expenses and all the rest of it. I want to be able to buy that as a service and not worry about it. So I think I'm going to have to get a pager again.
Or you're going to just hire Soluna. I mean, it's going to be managed service. It's going to be a managed service delivery.
Okay, all right.
Not you shouldn't invest in your own infrastructure again. I agree. So there's a middle there where you're hiring companies to build your own specific stack, for this purpose.
So you'll get the pager.
Yeah. I used to have one, by the way. And long story.
I think existing cloud vendors are going to get even more powerful, and I think to his point, I think that enterprises will not want to own a lot of those parts of the stack, if you will, themselves. I think they would want to own as little as possible, and part of the reason why we see so deep level of partnerships between the chips manufacturer and all the cloud vendors is for essentially for cloud vendors to ensure that all those capabilities that you're talking about, something around security, data leakage and whatnot, is kind of already plugged in when I, as an end customer, might be using an application to train a model which is underlying on the underlying using a GPU and whatnot. So I somehow feel that there of course will be a lot of enterprises being able to use more application than harness the power of generative AI, but I think a lot of that will come through the cloud vendors themselves.
I think that it's absolutely the case that enterprises don't want to own any more depreciating assets than they have to. But at the same time, I think there's, the driver for a lot of these decisions do come down to the governance boundary and who owns that. And I was speaking to the chief analytics officer or the head of AI at IRS, for instance, and his data set is literally the tax information for every single American citizen. And it doesn't matter what promises a cloud vendor, how many promises a cloud vendor gives him. He has a called in front of Congress level sort of fear of letting any of the data outside of his governance boundary. Right?
Also, tax data will never run out, will it? There's always going to be more.
Exactly.
That's right. I believe death and taxes, are sort of always going to be there. But the point is that, and that's a fairly extreme case, right? But I think every business has different levels of sensitivity to data. And the interesting thing about the AI applications, I think, we've been talking about data is the new oil and big data and all this stuff for well over a decade. But with AI, people are starting to, I think, understand, oh, that's oil, but now we have an internal combustion engine, which motivates actually what that oil could do for us. All of a sudden, it's very interesting. And so I had, I think, 3 months or 4 months after ChatGPT first came out, I was talking to various customers and trying to just take the temperature of how they were thinking about it. And they were I was surprised by how utterly sensitive and cautious they were about letting any of their data go out into these, cloud hosted AI as a service kind of places. They were extremely jealous of it. They instantly, very quickly, it wasn't like it took years for them to understand. They very quickly understood, oh my God, my data could end up in here. Some intern somewhere could flip the wrong bit, run the wrong bash script, and all of a sudden, GPT-3 at that time, would be giving up proprietary data to some rando, right? And so the sensitivity, the power of AI, I think people do see. People believe the promise of it, and that increases their sensitivity. So those sort of GRC and compliance boundaries actually become more significant for people. So even though, and I do agree with you, they don't want to own depreciating assets, they will go to managed services or go to cloud vendors, but I think they will much more consume a commodity level of service from them, and they will have a lot more opinion about what they own, and they will definitely have very strong governance on how the data actually moves in those environments.
It's just going to be more work for the procurement and security department to go and do next level vendor assessments about where data's and what models they're using, right?
Yeah, 100%. I was listening to this podcast this weekend, and it was an interview with the CIO, the Chief Information Officer of Goldman Sachs. Anybody here from Goldman Sachs? Former Goldman. So in the podcast, they talked about the use cases, how they're approaching this technology, the same concept, bringing in the large language model, training it, using RAG and all this kind of stuff. And then they asked them, so where did you guys are a financial institution, you got all these regulations, where is the stuff? And they said, well, it's a good question. We're really worried about our data and we don't want our stuff out there. We don't want it inside the model. So we basically called our vendor and said, give me this many GPUs. That was a lot. We wanted to be in his own rack, separate building, all the way down to the person who can, access the root and get access to the actual storage, unit on those systems. They need to know who it is, and they need to have override for that access. So it's gotten to a point where they're in the cloud, but they've effectively sort of recreated their own data center inside of that environment and has it delivered back to them. Obviously, they're Goldman, so they can get people to do that. But for their perspective, that's the only way to play around with this technology. It's just too dangerous.
Yeah, I think people forget maybe the sheer jaw-droppingly high level of compression that these things represent. That we can have on a USB stick or a thumb drive, you can fit a series of weights, just a big old NumPy array in a sense. But on a thumb drive, you can fit something which, with the right little bits of code, I mean, the inference part of the code for these models is not that large. You have a thumb drive, you have that, and then you can actually ask questions about the sum total of human knowledge on a USB stick. Now, if you are Goldman Sachs, if you're any kind of a firm with a lot of corporate documents and procurement documents and contracts and proprietary data on your designs and everything else like that, the more you put into the AI, the more you try to leverage AI and LLMs, the greater risk exposure you have in a very small artifact. I mean, if it took a dump truck to haul the data out of there, well, that'd be one thing. But it doesn't. It takes a USB drive, which is why it's totally makes sense that the Goldman folks want to know who it is that could even approach the perimeter of that building.
You can't touch
right?
that thing. Yeah.
Yeah.
Awesome. Well, we talked about data security quite a bit, but let's move on to a little bit about the ecosystem, right? So we know, hardware, the chips industry is dominated by a very prominent chip manufacturer. And we also know the clouds are also very dominated by a few big players, and data center and clouds are both very concentrated industry. So what are your thoughts on any kind of innovation and any kind of projection could change that current industry dynamics? And similarly, on a similar track, we also see we have open source models and we have closed source models, and we also see open source versus closed source, data center technology, CUDA being more, versus PyTorch, etc. I'm thinking, how do you guys think about these trade-offs? And if I were a company, I'm trying to do this, am I locked into a certain ecosystem already, or is there a lot of flexibility for me to change?
I can start if it's okay, guys. I started my career at Intel 20 plus years ago, 25, 28. Okay, I'm old. But they were the king at the time in the CPU space, right? 88% of the global market. And, that's after a near death in memory. And the market then began to fragment after a while, right? You had other players eat market share, AMD, et cetera. But they remain the dominant player. And to this day, they remain the dominant player. Now, I'm sad because, they missed AI, they missed mobile. So they're not going to be the beneficiary of this growth. NVIDIA, I'm proud of because they've gone through 30 years of pain and suffering to become this dominant player. I think the market will ultimately continue to evolve and sort of rest with having, one or two companies pretty much dominate the space. And the reason for that is the sheer amount of capital and infrastructure and things you need to get right all the time to be successful in being in that space. Right. So if you haven't read this book called Chip War, I think it's by Chris Miller. Fantastic book. It'll take you through the entire journey from the initial discovery of the transistor all the way out to today, actually, where chips really pretty much are becoming geopolitical, technologies at this point. And so as this technology evolves, you're going to have to concentrate investments and capabilities to do it at scale. And so it will inure to a key, set of companies that can do that around the world. And that whole ecosystem will evolve over time, but it will definitely benefit a handful of companies. And I think there will be innovations. So things like better chips, ASICs, new efficiencies in model design that will enhance that. But fundamentally, you want to be able to rely on this technology. And so you want to make sure it gets built the same way every time, et cetera.
I completely agree. I think we're definitely seeing NVIDIA kind of running far ahead in the race, but there are more systems and more companies that are kind of trying to catch up. I mean, we heard from the Samba Nova team right before this. There are other products like Grok in the market, which is specifically used for the inference part of the problem statement. So their tensor streaming processors are built on a single core versus most of NVIDIA's chips are more multi-core. So I think there is more and more innovation that is happening, I think, to an earlier point about specific use cases and going all the way down to the chip level to solve for those specific use cases really well. So I think it's an evolving market, and we'll continue to see more innovation across the stack and how chips are being built.
Yeah, I think it's worth. I like taking the historical view because we really are at a moment in history right now, right? And if you look at the historical view, the fact that NVIDIA GPUs are good for doing AI, it really rests on the fact that they're good at doing matrix math in a general purpose way. And that was really the result of about 10 years of people mucking around with their custom shaders that they supported. And they had a very, very intelligent, or they made a commitment that their API wouldn't change. So you could sort of write code to work across all of their chips. And you write these, shaders and whatnot, and that ultimately evolved into being CUDA, right? And that was a really important software world lesson that a hardware vendor was manifesting. Because in the software world, if you have an API and you have people writing to the API, you don't break the API. I think Linus Torvalds, his like sort of first commandment is never break userland. You can do whatever you want with the Linux kernel, never break userland. And so NVIDIA's dominance with CUDA is because they have not broken CUDA for people. It will work on all these different chips. Whereas when you hear people griping online on Twitter, trying to get stuff working with ROCm on AMD, it's like, which chips does this even work on? And so there's definitely the idea that hardware vendors taking a view towards making the software enablement of the software ecosystem really, really important. And it's interesting to watch all of them sort of clue into how NVIDIA did it and built their software moat around CUDA, which I think, there's no particular magic there. It's matrix math. Everyone knows how to do matrix math. Okay, fabbing in 4 nanometers, only a few people can do that. But ultimately, there's not really any secret sauce in there, some magic elf. It's pretty well known. You just have to do a lot of things right. So that's why I think that as this space evolves and matures, we will see a lot more competition, especially going into the long tail of use cases. Right. So there's a lot of AI things or things you might do with AI right now you wouldn't think about doing. And there's this term of like a compute that's too cheap to meter. I don't know if people have heard that term, that we got to a point where you just throw a computer into a door because it just works. Your electric door just works, right? It's computation that's too cheap to even to meter. AI right now is not too cheap to meter. It's extremely expensive, right? But when that starts becoming too cheap to meter, the kinds of algorithms that people will be innovating on, the kinds of topologies you can use, the kind of chips that people can make at 12 nanometers, you don't have to be constrained by just those machines, extreme UV machines at TSMC. You're going to have an explosion, right? Nature abhors a vacuum. And if a couple of grad students in some random university can get their hands on a bunch of really cool, but mid-tier hardware, you're going to get interesting algorithms popping out of that will then, because it's all open source, all this AI stuff happens open source software, it's going to just, revolutionize overnight how people do things. So I think it's right now really dangerous to bet on the current dominant players to perpetually be dominant. They, of course, if they have $1 trillion market share or market cap, that's a lot of a war chest to go and win with. But we're still in the first innings of this game. And I think lots of things will diversify.
I think just to add to that, interesting point, like current state of the art chips are mediocre chips tomorrow. NVIDIA itself is coming out with Blackwell, which is like 2.5 times more performant, only being 25% expensive. So that will in some way, when it comes out in like public domain in 2 years, will make the H100 somewhat redundant. And we just saw H100 come to kind of the mainframe in the last 6 months or 1 year. So just the way and the pace of how hardware is kind of moving is also kind of quite fascinating.
Yeah, and this is just repeating. So how many people here use Novell NetWare for their computing networks?
Same.
It just got abstracted, simplified, and removed, right? The complexity is still there. Frankly, honestly, I wonder I'm amazed every day that the internet even works. If you ever really looked at the levels of complexity, the software, the hardware, everything in there, it's a miracle it works. And I think, we've been through, and I've seen in my career that, you must have 2 vendors because you can't rely on one. They'll squeeze you for cost and they're not reliable. Then we all got relaxed and said, it's kind of mostly reliable enough and it's cheap enough that we won't worry about it too much, and we've simplified. We will go through that same process again of adding complexity. Operational issues will come from that. We will abstract it and simplify. It will get cheaper, and then it'll get absorbed back into the infrastructure of IT. So we are going to have to ride that through a little bit. Back to your original question, which is like, what's the impact on ecosystems for enterprise? Complexity is coming a little bit, and then we will simplify and come through. But it's no reason not to push for change, because there's enormous promise in some of this technology. We just have to bear it. Plus, Peter's the one with the pager, so I don't care.
Him. I did actually bear.
John is the one with the pager.
John's the one with the pager.
I actually did a stint as an IT guy, so I have a lot of appreciation for the craziness of the hardware and the networking stuff. But to build on that, I think the organizational lesson here is, I think a lot of business, especially big businesses, especially when we get into enterprise IT and CIO, CTO, best practices and magic quadrants and all this stuff, there's a tremendous amount of decision making based on risk aversion. And I think right now the most dangerous thing is to operate in a risk averse mode in this area, in the sense, not that you should just put all your data out there, but just that recognize that you're going to be doing things and some of those things are going to not work out. but you should empower those people to do those things, because of the 5 things you try, 1 will work out, and that's going to be your path forward. And if you're too afraid trying to figure out, design a decision by committee, which path should we commit to, but just one path, you're almost certainly going to always be left behind, right? And to give people a sense of just the degree of potential transformation we can have in this, not even just the fact that, Blackwell is going to be so much better than H100s, but if you look at right now the fact that people go and they buy all these expensive, or they rent expensive H100s with InfiniBand to do what? To do matrix math across a large amount of GPUs, because each one doesn't have enough memory. So they have to have the extremely fast interconnects. But why? Why do you do this matrix math? Well, because backpropagation. One particular aspect of an algorithm that we sort of stumbled into a few years back, honestly, is what drives the $1 trillion market cap of NVIDIA, right? So what's to say there's not another algorithm tomorrow, right? And you say, well, maybe we're optimal. Well, consider this. You take one of these large, massive models, state-of-the-art models, and if you go and you look on Hugging Face, people go and quantize them. They take them down to 4 bits. They take them down to, actually, BitNet shows 1.5 bits, okay? You can quantize a model that cost millions of dollars to train on giant amounts of infrastructure. You can quantize it down to a fraction of the size, and it's like 90% as good. So somewhere in the middle of everything we're doing, it's amazing it works at all, but somewhere there must be some significant inefficiencies if we're going and doing all this amazing matrix math only to then be able to squish it down and compress it to a fraction of the size and have it still be as efficacious. So that for me is sort of it's kind of a hand-wavy argument, but it's an intuition that big changes are coming and big optimizations are available.
Maybe some of the challenges are also kind of driving some of these innovation. I mean, you talked about model pruning, like there is model distillation. And I mean, the whole concept of small models came, part of the reason why it all kind of triggered together was because of this. So I think it's one of those cases where constraints is driving innovation. So I think probably I'll put this in that category.
Yeah, on the power constraint side, you don't need to put Blackwell everywhere in all of those managed centers, right? You could go back to L40Ss or A100s and put massive amounts of them next to a renewable energy plant and have a really powerful computer that can do a lot of tuning and inferencing for an enterprise at a fraction of the cost of what people are proposing for some of these newer chips. And so you definitely have to think differently, and you definitely have to invest. I second the idea that risk aversion is a death knell for any enterprise today.
Okay, well, we have 2 minutes, so why don't I have you guys think, give a 30 seconds your concluding thoughts, and maybe what you think of the most fascinating, most innovative things happening that throughout the ecosystem. Maybe that'll break some of the dominance we're talking about.
Yeah, final thoughts. I've got a perpetual license for 20 NetWare clients. If anyone's interested, let me know. I don't need them anymore. You can have those. I actually, of all the things I'm involved in, that the ability for the model prediction, back to the prediction being a primary driver in healthcare, I'm involved in ultrasound is profound. So, the ability to take the compute and apply it in ways that a human just can't do is profound. And I think we'll see a lot of advances in that. So I'm excited by that.
I think I very strongly feel that the AI super cycle is very much in the infrastructure build out phase. And we're already starting to see some early shoots of companies, whether cloud vendors or end customers, starting to generate revenue. It's still very early days, but I think there are early signs that these things will probably make a lot more justification of the capex spend that is being happening.
For me, I guess the most interesting thing that I'm tracking is this idea that the larger the model is, the more it becomes essentially an approximation of a universal model. And that essentially Gemini, GPT for OpenAI, Llama, all these, ultimately, the bigger they get, the more they are actually just the same model underneath. And so actually, if you have smaller data sets or more domain-specific ones, then you actually have more differentiation. And the interesting thing is, if you can build a public and free version of a large model like this, and it is universal, to some extent, you are taking all of that knowledge in those massive models and you're making it into a commons, an object that's actually free and not renderable as property. And so some of these very large, very, very heavily capitalized investments into state-of-the-art models may ultimately end up being things that can't be made into intellectual property. So anyway, tracking that sort of monosemantic representations and universal modeling thing.
From my perspective, for the last 6 years, I've been working on making renewable energy a global superpower using computing as a catalyst. And what excites me to no end is that this technology has the potential to really catapult the amount of renewable energy and help us to address a lot of the climate change issues we have out there. And I think that enterprise is both the largest potential beneficiary of this technology and also the one with the most responsibility to make sure that we do it in a sustainable way.
Wow, that was fascinating. I feel like I could sit here for another hour and discussing these issues, but we have time limited. And thank you so much.
Thank you.
Thank you.
Thank you.